Hello everyone. My name is Asad, and I'm going to present you the implementation of Auto Supervisor AI agent. I would like to thank the team to believe in me and give me this wonderful opportunity to work on this project. This was really a great learning journey for me. Uh, so first of all, I would like to show you the architecture, full stack monorepo architecture, in which we have a backend. In the backend, I am using UV and Fast API along with Pydantic. In the front end, I'm using Next.js, as was mentioned, along with Tailwind CSS and Sharp.cn. Also, I'm using Docker for containerization, Docker desktop basically, as this is a Windows system. This Docker desktop up. Before we move, I would like to show you the architecture. So basic architecture includes a front end, back end, agent orchestration, uh, basically temporal Python SDK, and we have some agent and policy runtime, which is an encode. The database that has been used is PostgreSQL, which is Superbase Cloud. This was a feature. Uh, Before I go deep into this, would like to show some notes that I've written. Why an AI agent is relevant for order supervision. As real-world e-commerce orders and logistics life cycles are quite noisy, non-deterministic, and unpredictable sometimes. An order can experience weather delays, payment declines, address corrections. So all this could be handled with the AI agent orchestration, also by using a CRM dashboard. Also, one thing that was necessary to define was to use LangGraph or not. As I think LangGraph is great for short-lived multi-step processes and LLM prompt training, but temporal is very good for durable execution, built for weeks, months. As order is sometimes order takes multiple days to reach. Also, the crash thing was very interesting. The workflow resumes in temporal where it slept even after the server restarts. Does not happen in LangGraph as of right now. If the server crashes mid-sleep, state must be reconstructed manually. So this is not automated by LangGraph itself. So these were some of my pointers that I used for the decision of using temporal only instead of using temporal plus uh, LangGraph. So as you can see, let's go through why order supervision and why order supervisor AI is necessary. A production-based system built to oversee long-running order life cycles from creation through final delivery. Uh, the solution was leveraged by use of temporal Python SDK and durable execution, which provides durable execution. For every new order, I instantiate a dedicated supervision workflow. It basically is one instance per order. Also, if we go through it, we have some single handlers in the orchestration engine, which is incoming event and add instruction that we will see in the UI. Also, the event driven structure, the wake sleep process, maintaining the workflow, persistent time and memory. These all are connected with temporal Python SDK and served there. This sends a check wake policy, a lightweight classifier policy. What this means? It means basically waking the agent up, checking some policies. If I inform the agent if the order has been delayed by some time, when to wake up, when to immediately take action, when to give the LLM the power to use some heavy LLMs or some light LLMs. Also, Open Router has been used for the entire flow and for LLM. Uh, because it can provide multiple models, and also the action selection is very good. Uh, One of the reasons that I don't or have not used a single OpenAI API or a Gemini APIs, we can not switch more agents up there. Open Router provides NVIDIA models, GLM models, and Llama models. So yeah, dispatch action. These are some mandatory business actions. Like imagine, when does the AI decide to message the user? When does the AI decide to message the logistics team, the payments team, or the delivery agent directly? As you can see, these are the tables. Okay, database. So yeah, these are the tables: supervisors, workflow runs, agent actions, run instructions, and timeline events. Some of this has been decided by me, and I have also used use of AI. I've mostly used open code with GLM, and sometimes for the UI anti-gravity. It's kind of good. So as you can see, workflow. This is the temporal local UI. If we create a run, workflow would appear in here. So I have created a demo guide. So in the demo guide, we can see it's written go to the supervisors and click create supervisor. Supervisors, some I have already created uh, the name. Okay, let's go and submit the base instruction. These are some of the action items that or available actions that are necessary. We can choose which to keep and which to not to keep. Wake up guidance. What is wake up guidance? It basically tells you to take action immediately to the AI agent if the payment has failed or a refund is requested. Let's create our supervisor. As you can see, it has been created. You can see here it has 8 tools, the action tools that we were talking about, updated just now. View, and you can start the run. Okay, for the run, I have already okay, copy here, go. You can launch the workflow. You can also read the system direction base instruction classifiers. Any runs would appear in here if we launch workflow. Okay, so you can see the event ingested in here. Timeline could appear here, memory summary, active history, inject event, run instructions, and final reports. So as you can see, order created. You don't have to create manually. Order ID is there. Workflow supervision started. You can see raw JSON also here. Order created, monitoring for payment and shipping status. So it's monitoring for payment. Let's send a payment confirmed, and we can write amount to be 1299 and inject event. And let's see and wait if inject event populates in the timeline or not. 3. Okay. As we can see, amount paid is this, transaction confirmed. Activity history is there to check intervals. A reason for timer, order created, monitoring for payment. This would get updated in a time. We can also write instruction here. If order is delayed, message user and assure support and escalate the issue. Okay, let's see. Okay, we have activity history, payment confirmed, monitoring for shipment status and potential delays. Let us do a delay. Do we have a delay? Payment failed here, shipment delay. Okay, can do a shipment delay here, and the severity could be high. Okay, waiting for any further actions by the agent. You can also see it in the raw JSON. Human use for someone who is like want to see it in very minimal form. Delay alert is there, 24 hours. FedEx, context evaluated clearly. Right. So these are all the things that you can see in the timeline. Activity history is also there. Logistic teams has been messaged. Order is delayed, disrupted. Tracking ID, FedEx Express, please investigate and expedite resolution to meet 24-hour delivery as much as soon as possible. So yeah, this was the uh, implementation of my agent. So there are also multiple supervisors or runs, as you can see. This was the run that I tried earlier. Order created, context validated, payment confirmed, shipment delayed. So you get AI agent cycle and multiple reports in here also. So as you can see here, email has been sent to the customer. Your order has been shipped. If the order has been shipped, they'll get an email properly and the flow gets closed. Uh, so yeah, so this was a VIP thing, right? So we sent the logistic team the message also, and we have also sent the message to the user for the order confirmation. So yeah, this was my entire implementation. Some filters on here was completed terminated. So yeah, I would really like to thank everyone from the team. This could improve a lot, uh, but I tried my best to implement this entire front end uh, and the backend process, which uses the app-based architecture. APIs of runs go in here, and yeah. So stopping the talk here. Thank you so much, guys.